Today I am now in the chapter alcohol, in which we study about nomenclature of alcohol. अल्कोहल का नामकरण कैसे होता है? There are two ways to nomenclate a compound of alcohol. One is common system nomenclature and other is IUPAC name. Now I am going to the common name. That is known as CN. The common name of the alkyl group and adding the word alcohol. For the example, CH3OH is methyl alcohol. Alcohol in common name nomenclature. Ethyl alcohol C2H5OH, alcohol, and serially propyl alcohol, butyl alcohol, and so on. But in this common name there are some of the structure that can be represented as isopropyl alcohol, that is CH3 CH3 1 2 3 and 4 CH2OH. That is called isopropyl alcohol. Isobutyl alcohol. It is called isobutyl alcohol. And CH3 CH3OH is called isopropyl alcohol. Isopropyl alcohol. And this is the another structure that is known as neopropyl alcohol, in which we study the CH3 and one carbon is bonded with first radical and first radical, therefore OH neo CH2OH, that is called neopentyl alcohol. Neopentyl alcohol. This is the structure for the common name nomenclature of organic compound of alcohol. As you know, this common name is more and more communicative in the some of the local areas as India, Pakistan, Sri Lanka, Bangladesh, Nepal, In this areas, CH3OH methyl alcohol is known as the common name of the organic compound of the alcohol. But here is another nomenclature, that is called IUPAC. The IUPAC system IUPAC system of nomenclature of an organic compound of alcohol that can be denoted by the suffix ol, alkane, and adding of suffix ol while replacing of e from an alkane and substituting of ol in the alkane that produce alkanol. Alkanol. Their formulation is said to be 2NH2N plus 1 ol. Ol tends to OH. Therefore, CH3OH is known as methanol, that is also known as hydroxy methane. Another compound C2H5OH is known as ethanol, that is hydroxy ethane. When we expressed it in expand order, then it is said to be CH3CH2OH 1 and 2, that is in numeral system by the IUPAC it can be pronounced as 1 ol ethane. Similarly, the another example of such type of compound of OL, that is alcohol, that is written as CH3 CHOH CH2 CH3. In this connection, we have to nomenclate such type of formulation as OH is attached to the second number of carbon. So when we go left to right in the numeral order, then we found here this CH attached to OH at the number of 2, which can be pronounced as 2 ol butane, or it is also pronounced as 2-methyl butanol, 2-methyl butanol. Two-methyl butanol. Hence, we are going to the nomenclature of phenol. Phenol, their structure is it is also known as benzyl alcohol, phenyl alcohol, hydroxy benzene. Now, according to expression of phenol, I would like to say that while learning the online वीडियो प्रोग्राम, आप ये चीज़ कभी नहीं भूलें कि किसी भी ऑनलाइन वीडियो प्रोग्राम को एट फर्स्ट सब्सक्राइब, शेयर और लाइक किया जाता है। तो आप इसे सब्सक्राइब, लाइक और शेयर अवश्य करें। थैंक यू। The phenol is the simplest derivative of benzene. It is the simplest derivative of benzene by OH functional group. For example, phenol, the first derivative of the benzene of the functional group OH. Second derivative of benzene is catechol, that is benzene 1,2-diol. Now I express the derivatives of alcohol of benzene, that is These are the derivatives of benzene of alcohol. Their consecutive name is catechol. Number 2, catechol, that is 1,2-diol benzene, and second is resorcine phenol, that is called 1,3-diol benzene, and fourth is benzene 1,4-diol. Their commercial name is catechol 1,2-diol benzene. Here the commercial name of these derivatives of benzene of alcohol is known as resorcinol, that is 1,3-diol benzene, and the commercial name of this fourth structure of benzene, in which OH, the functional group, is placed at number 1 of carbon and number 4 of carbon, that is called hydroquinone. It is also known as quinol. And 1,4-diol benzene. These are the derivatives of benzene of alcohol, in which you have to study when OH is placed at first carbon, that is known as phenol, and when OH is at number 1 and 2, that is called catechol, which is number 1 and 2, so it is called diol benzene, that is number 1, number 2. Similarly, third structure in which OH is at 1 and 3 place, that is called resorcinol 1,3-diol benzene, and here OH is at 1 and 4, that is called hydroquinone, that is quinol 1,4-diol benzene. According to the other structure of such type of organic compound that is related with, bonded with the OH functional group and any of the radical, their pronunciation is belonging under the same conditions, that is as which can be expressed in front of you. That is, if the structure of benzene is drawn, as you know, the structure of benzene is alternatingly single and double bond of sp2 hybridization, which is bonded by CH3 and OH. On the first carbon, CHE is tagged, whereas on the second carbon OH is tagged. Means 1 and 2 methyl phenol, 2 methyl phenol. In such a structure, we always introduce by the name at the last phenol terms. Similarly, one of other example of same structure that is given here CH3 and OH at the fourth position of the carbon, then it can be derived as 4 methyl phenol. The structure of functional group. Now I am coming to the structure of functional group of hydroxy. Hydroxy is a combination of oxygen and hydrogen, that is defined as the OH. As you study in all the classes of alcohol, which Lewis bonding and dash bonding, that also define the bonding between hydrogen and oxygen, as also given you, that is hydroxy group O, that outermost electrons is 6, whereas hydrogen outermost electrons is 1. Here it covalent with oxygen by the sharing of 1 electrons, that give us O bond H. In the alcohol, the oxygen of OH is attached to carbon by the sigma bond. Oxygen attached to carbon by the sigma bond due to overlapping of carbon by the sp3 हाइब्रिडाइजेशन. यहाँ पर हाइब्रिडाइजेशन sp3 का होता है कार्बन और ऑक्सीजन के बीच, जो इस प्रकार से हम दिखा सकते हैं कि ड्यू टू ओवरलैपिंग ऑफ sp3 हाइब्रिडाइजेशन ऑफ कार्बन विथ hybridized orbital of the oxygen, means carbon, oxygen and hydrogen. There is 4 electrons in its outermost. 3 of the electrons bonded with hydrogen as this way. And the 4th electrons of carbon bonded with oxygen by the sigma bond, and one of the electrons of oxygen bonded with hydrogen by also a sigma bond, but rest of the electrons which are in 2 ways as the lone pair of electrons. So here is the bonding between carbon and hydrogen is by the sigma, and oxygen and hydrogen is by the sigma, but carbon makes its octet due to sp3 hybridization over the O. So the octaves are in this way. With hydrogen and oxygen. It can be represented as in this way. Here the two lone pair of electrons of oxygen, that is hybridized with carbon due to the sp3, and the bonding between carbon and oxygen is by the sigma bond. Their bond length is 142 pm, and bond angle is 108.9 degree. In this way, the bonding is play their role between the carbon and oxygen. Now, the second example of benzene alcohol, that is phenol. As we draw a structure of benzene is in this order, that is double bond, single bond, double bond, single bond, double bond, single bond. Here O bonded with oxygen and hydrogen is bonded with oxygen. Therefore, the bonding between the benzene and hydrogen with the oxygen orbitals is by the angle of 109 degree, but their bond length is 136 pm. In this both structure, we have got some difference. The angle between the carbon with hydrogen by the sigma bond hybridized by the sp2 hybridization, the angle of phenol is slightly larger than the angle of methyl alcohol, but their bond length is slightly lower than the CH3OH. These are the difference between phenol and the methyl alcohol. According to the structure of phenol and methyl alcohol, we have to already study the there is a slightly difference in bond angle of phenol and the methyl alcohol, but bond length is shorter than the methyl alcohol. Why is angle of phenol is larger than the methyl alcohol? Their bond length is maximum than the phenol. It is depends on number 1, due to partial double bond in the phenol. 1 by 1 single and double bond in the phenol, that is called partial double bond in the phenol. Point number 2, sp2 hybridized state of carbon to which oxygen is attached. In this structure, oxygen is attached with the carbon by the sp2 hybridization, but here the oxygen is added with carbon by the sp3 hybridization. These are the main difference between phenol and the methyl alcohol. Thank you. For the next online classes, I am going to discuss about the chemical properties of the phenol. That is most important things. Thank you, and always remember, while watching the video, always remember, at first subscribe, share and like the video. Thank you. Best of luck.